Okay everyone, in today's lesson we're going to talk about factoring simple trinomials. This is a very important lesson, so make sure you follow closely. Factoring a quadratic trinomial, okay, like a parabola, from standard form gives you factored form. And that's why we are doing what we are doing, is so that we can ultimately graph our parabola using the information we can get from factored form. Let's do an example here. Factor x squared plus 5x plus 6. We need two numbers. We need two numbers that add to 5. Where am I getting 5 from? 5 is the coefficient of my x. I also need two numbers that multiply to 6. 6 is my last number. It's the one that doesn't have a coefficient. These are the rules of the game. We need the numbers that add to 5 and multiply to 6. The easiest way to do this is to start a factor chart for the number 6. One times 6, 2 times 3. There's not much else. Now what I'm going to do is I'm going to add them together. 1 plus 6 is 7. 2 plus 3 is 5. And so we have just found our two numbers. 2 and 3 multiply to 6, and they add to 5. Those are the numbers that we are going to be using. We then just have to write out our factored equation. Remember, your factored equation looks like this with two brackets and an x in the front. Here we're going to write out our two numbers. X plus 2 and x plus 3. Nice and easy. All I did was write the numbers in the brackets. It does not matter which order you put them in. You could put the 3 here and then the 2 there. It does not make a difference. We're just going to double check and make sure that we have factored correctly, and that's by expanding by multiplying. I'm going to use the rainbow method to expand here. So I'm going to go x plus x times x is x squared. X times 3 is 3x. 2 times x is 2x. 2 times 3 is 6. I combine my like terms in the middle to give me x squared plus 5x plus 6. Not so bad. That is exactly where I started from, and so I know that I have done this correctly. We have just seen an example where b, which is the coefficient beside x, is a positive number. And when c, which is the number that's on its own, is also a positive. I knew that both of the numbers that I was going to come up with were going to be positive, but that's not always the case. Let's look at another example here. X squared minus 10x plus 24. The very first thing that I'm always going to do is try to find the two numbers that are add to 10. So we need to add to 10 and multiply to 24. Add to 10, multiply to 24. We'll deal with the negative sign in just a minute. I start by writing out my factor table for the number 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. I add them together. 1 plus 24 is 24. 2 plus 12 is 14. 3 plus 8 is 11. 4 plus 6 is 10. And bingo, we have found what we were looking for. 4 plus 6 is 10. Those are my two numbers. I'm going to write out my template here with x in the front. Now, in this example, b was a negative number. c was positive. And so in this case, both of the numbers that I found have to be negative. So I'm going to put negative signs here, and then 4 and 6, and fill in the table. Okay, if you want to expand and just double check, we can do that. X times x is x squared. X times negative 6 is negative 6x. Negative 4 times x is negative 4x. Negative 4 times negative 6 is positive 24. I combine my like terms in the middle here to give me x squared minus 10x plus 24, which is identical to what the question was asking. Let's look at another example here, except this time I have two negatives. I have x squared minus 2x and minus 3. Very first thing that we're going to do is write out our factor table for the number 3. There's only one factor for 3, and it's 1 and 3, so this is nice and easy. In this instance, I have b as a negative number and c is a negative number. There's a minus sign here and there's a minus sign here. In this case, I need one number to be positive and one number to be negative. And the smaller number is the positive one. Let's take a look here. 1 and 3 are my factors. The smaller one has to be negative. So if I have a negative 1, or the smaller number has to be positive. If I have a positive 1 and a negative 3 and I add those together, that gives me negative 2. So I can go ahead, that works out perfectly, negative 2 and 2. I can go ahead and I can write my factored form, x and x. I have a positive 1 here, and I have a negative 3. And that is my final solution. Let's just double check by expanding. X times x is x squared. X times negative 3 is negative 3x. 1 times x is positive 1x. 1 times negative 3 is negative 3. I collect like terms in the middle. That gives me x squared minus 2x minus 3. Okay, and there you have it. One last example here. X squared plus x minus 2. In this case, b is positive, c is negative. I have a plus and then a minus. So when b is positive and c is negative, one number is going to be positive, one number is going to be negative, and my larger number is going to be the positive one. Let's take a look here. 2 is what I need to multiply to. The only way to do that is 1 times 2. Okay. Here, I need my larger number to be the positive 1 and my smaller number to be the negative 1. Negative 1 plus 2 is 1, and that's the coefficient that I have here, so we know that this works out. Let's go ahead and write our factored form. We put our x's in the front. I have a negative 1 here, a positive 2 here. We can check by expanding. X times x is x squared. X times 2 is 2x. Negative 1 times x is negative x. Negative 1 times positive 2 is negative 2. So my answer here is going to be x squared. I combine these like terms to give me just x. And our answer is identical to what the question was asking for. Once you get the hang of doing these types of problems, you don't need to write out all of these long steps, okay? Once you really get into the rhythm of it, it's going to be fine. You don't need to do this. You might not even need to refer to this table anymore. It's just going to become really fluid. But it is going to take a lot of practice for you to get there. So I do strongly encourage you to practice, practice, practice before doing any kind of assessments.